Hey, welcome everybody. I'm going to be talking about some Windows stuff today. Not a lot in the way of slides. It's going to be mostly live demos. Hopefully nothing completely blows up on me. If I could just get like a quick show of hands, how many people are Puppet users right now? Okay, so we got a good percentage of our already users. And how many people are using Puppet on Windows right now? Okay, good. So I can probably skip over some of the intro-y stuff. Wasn't sure exactly what the kind of composition of people was going to be for this, so try to hopefully prepare for that. So again, yeah, my name is Ethan Brown. I'm a senior software engineer at Puppet. I've been here for about a year. In my early days, I was a C++ comm guy. I kind of have a lot of battle wounds to show for that one. I've been doing .NET stuff basically since before it was released. PowerShell pretty much since it was released. So all in all, about 20 years of doing Windows development. At my last job, I kind of fell into DevOps by default prior to joining Puppet, and we didn't have any ops guys, really small startup, so that was how I kind of got into Puppet. And yeah, most recently I've done a lot of the x64 work for Puppet, and also the Azure integration work that we have that helps install the Puppet agent on Azure VMs, and we ship a Puppet Master VM that's easy to spin up for people. So I'm sure you guys have probably all seen this. I saw a lot of hands that are for Puppet users. You're pretty familiar with this stuff. Grab facts off of a node, send that to the Puppet Master, build up a catalog, send it to the agent, report back. So everyone's, I'm sure, pretty familiar with that. So with that being said, let's do some demo stuff. So first and foremost, I want to talk just a couple of minutes about what my demo environment looks like. So I have a CentOS master that I've set up inside of a Vagrant setup. And I've also got a Windows 2012 R2 agent. And there's a bit of configuration that I used. I used a plugin that actually Charlie helped work on called Oscar that helps you to kind of bootstrap the process of preparing nodes to be set up in an environment like this. So part of what that does is grabs PE versions, automatically installs those, slipstreams those kind of into the Vagrant box, and also does a bit of configuration with respect to hosts, so that in your little private Vagrant network setup, the hosts can communicate with one another. So there's a bit of info in this. And just so you know, all of this code, I designed this workshop for people to be able to pull down locally to their own machines and just do a Vagrant up. We can talk a little bit more about that later, but all the code is out on GitHub, and I'll share that link with you guys in a little bit. So yeah, this is basically what we're doing in terms of provisioning things. There's some particular setup for Windows in opening up the WinRM ports. This one's a particularly nasty one that I ran into where my clipboard got completely corrupted by VirtualBox if I didn't disable it, so that's something to be aware of. It's kind of a big issue. So let's get into, real quickly, the VM that I have set up. So one way to do that is we can do Vagrant RDP, and I have a Win 2012 agent. Or what we can do is, I've already got this up and running for the sake of brevity, so we can hop in and take a look kind of at my Windows setup here. So you can see I kind of put Windows into, this is geriatric edition with monster fonts. So hopefully everybody can see this really well. Kind of went overboard. So one of the kind of the first things to be aware of is that configuration data is stored in a different location on Windows than it is on Linux operating systems. We have a program data Puppet Labs. This is actually the all users profile directory that we use. So it's going to vary if you're installing on 2003. But up-level Windows, generally speaking, is going to be in C program data. So we have a Puppet Labs directory. And then inside of there, we have a bunch of configuration information, not just for Puppet itself, but for Factor, Hira, and mcollective. And as part of preparing this demo, I already primed the Windows box and had it do one initial connection with the master to get mcollective set up so that we don't have to look at that kind of output during the course of the demo. So let's talk a little bit about facts and what we could do on Windows with facts. So I prepared a couple of facts already. A couple of them are text-based, a couple of them are PowerShell-based. And let's just take a quick look at what the PowerShell, oops, don't want that. Actually, let's do it off of, we'll just do, yeah, we'll run this guy directly. Let's do that. So the program data, Puppet Labs, factor, facts.d, and I have a Windows feature fact that I hooked up. All this basically does is call a standard PowerShell commandlet to dump out the Windows features that you have installed on your machine. So we can see we have file and storage service, storage services, .NET Framework's already installed as part of how this base box was put together. And that fact in particular is going to look like, so this is the actual PowerShell code for this fact. You can see that I'm actually doing kind of a little trick here based on the current version of Puppet that's as part of PE that's running on this Windows machine. We actually have to make sure that in this case we're calling against 64-bit PowerShell because the commandlets that we need to access get Windows feature in particular is not available on 32-bit PowerShell. So I kind of wrote this fact in a kind of a slightly tricky way to be able to kind of capture the actual fact code that I want to execute into a little into a block like this. And then based on what the size of an int pointer is, which is kind of some gory details about a way that you can identify whether you're running under 64-bit PowerShell or 32-bit PowerShell, we can make sure that we call out to 64-bit PowerShell and we dump the output of that. So the standard fact output is, you know, x equals y, that sort of thing. And we can see that over here where we have Windows features equal. And then basically I just dump out, for this particular version of factor, we just have a list that's comma delimited. So we also have let's take a look actually at Textbased Fact. And we can see that that guy is just database role equals true, which is going to kind of come into play later in the demo when we start to do a little bit of node classification to determine what we're going to be installing on nodes. OK, so another thing that I wanted to show in line with facts was kind of the old way you might have done something if you were using like WMI or something to that effect. So I cooked up some really nasty, ugly-looking facts, or things that might be facts but aren't Puppet facts. So this would be calling out to WMIC to get the last boot uptime. So you can see that's a pretty ugly way of doing things. And when we actually run this thing, we're going to get like a really nasty, like hardly parsable. You know, you need to write some additional code beyond that to actually parse the uptime, right? You know, we can do a little bit better with straight up PowerShell. If I can find which, yeah. So I wrote one called get system uptime. And of course, we get back a .NET object that again is going to need some formatting. Or we can just, you know, use factor. This is kind of just a demo of like what you might be encountering if you were trying to capture some of this system information, like by hand if you were rolling your own or using it in some sort of other kind of automated setup that you were trying to kind of put together on your own. Obviously, factor has a lot of this stuff kind of hand rolled into, or kind of built into it. And you can see that web role that I had earlier, and there's a database role that I set to true with those text-based facts are in the factor output. You also see all this Windows feature stuff. This is just some basic fact stuff just to show you guys how we're going to end up identifying these nodes or classifying these nodes a little bit later. So let's log also into our PE console. And of course, the PE bug there. And let's take a look at our agent. And we can see where database role has gone from the agent back up to the master. So again, pretty standard stuff if you use this stuff on Linux. Pretty much the same sort of thing, aside from the fact that we don't run, generally speaking, we don't run bash scripts on Windows. We run PowerShell instead, or batch files and that sort of thing. And there's the Windows feature as well. So the next thing I want to talk about is resources and how we can get resources, how we can use that tool at the command line to grab resource data from Puppet, and how that might look on Windows, and what things in particular are going to apply to Windows. So let's go. I'm going to go back over to my command prompt here. So first off, again, standard kind of Puppet stuff is that we can do Puppet resource types. We can get a list of all the different types that we can use on Windows. or that we can use in general, but not all of these are applicable on Windows. So you see a lot of Nagios type things. Those we intend to, I think, pull out in the next version of Puppet. There's a bunch of other things here that are not really applicable. However, kind of the standard fare, run-of-the-mill file, scheduled task, service. Let's do it like service, for instance. We get all the output of all of the running services, or all of the services, whether they're running or not. So we can see stopped services. We can see things that are either enabled or disabled, whether they're manual start or automatic start, that sort of thing. Okay. So again, pretty much all standard Puppet stuff in terms of resource description that you would use on other operating systems. We'll kind of skip over some more. I had some more examples, but let's skip those in the sake of getting to the more fun stuff later. Okay, so let's talk about how you might create a user old style. So we're going to take a look at computer management. This is the old classic, I'm a Windows guy, I want to go in and I want to create a user on this local machine. I haven't automated anything. I think everyone should be pretty familiar with this particular UI. I'm going to create a user. Right, not so awesome. Not so easy to automate. Now, if we want to do that same sort of thing, let me type this guy out first. Oops. This is how we would do it if we were going to script it with old style NetUser. Now, the problem with NetUser is that what happens when the user already exists? So let's run this. Oops, let's not run that. Let's run user add. And we see the account already exists, right? So we haven't done anything to ensure and check whether or not this user exists before we try to apply this change. And of course, that's going to result in an error. So we can kind of take this to the next step. And we can try to write this in PowerShell again, like, hey, let's do this in PowerShell. We've got this great tool that's built into Windows. Let's use it. Oops, I think I called it add local user. And I think I gave it a parameter of, nope, no parameters. Oh, it would help to run that in PowerShell rather than command, huh? And we'll do a username of Bob, which is the user that we created. And at least we can write some code. This is the actual script for this. So we're using ADSI here. And at least I improved on my batch file by at least performing a check through ADSI to make sure, hey, did this user exist or not? And so we can kind of safely exit out of this without completely blowing up and trying to create a user that already exists. So that's a little bit better. It's still not great because it becomes difficult. Like, how are you going to script this from a centralized point of location? How are you going to report on this? How are you going to know if you're going through a series of machines whether or not something lost that user account, right? So the next thing that we can kind of do is we can write this in Puppet. Let me bump this up a little bit. So with Puppet, we can just declare that we want this user to exist. We want him to be present. We want to be able to create his home directory, which is this manage home true. We want to set a password. Obviously, don't do this in real production work. And we want him to make him a member of a couple of groups. So if we took that PowerShell code that we were just looking at, we don't have anything like that in here. We don't have adding him to the groups. We don't have making sure that the home directory is created. In fact, if we take a look at one directory up in the users directory, there's no Bob directory there. His home directory was never created. So Puppet enables you to kind of do this a little bit better. So let's do a Puppet apply of that manifest. And of course, look at that, I have a syntax error. Oops, forgot a comma. I swear I ran through this at least once. I'm sorry?
Can you call Puppet in the PowerShell window?
Can I call Puppet from PowerShell? Oh, yeah, absolutely. I was just making it, I thought that the green would be a little bit easier to read on the black than the stock PowerShell window. So what we can see here is that we did create a user Jim. And importantly, if we try to run this again, see again the catalog is compiled just as it was last time. Or this time, we can see that there was nothing reported back because there were no actions that needed to be performed on the system. Now if we wanted to instead change this to absent, remove the user, now again, if we were to try to modify our PowerShell script, well, now we got to like rewrite the entire thing, right? We didn't take into account removing a user at all. But in a Puppet manifest, we can just say that we want to remove that user. Very simple change. We'll let Puppet enforce that configuration. And we get an error. Uh-oh. So let's skip that error. We do see that the user's home directory has been removed. And again, if we want to double check and verify, and here, our guy Jim has been successfully removed from the system. So the next thing that we might want to do is take a look at a simple PowerShell exec. So one of the things that we can do, just like we can do on Linux, is we can use the exec resource type to execute arbitrary code on the machine. And in this case, what we're going to do is execute some PowerShell rather than some bash script. So for this, I've written a little bit of code for disabling the indexing service. And there's a couple of files that we're going to take a look at here. So let's say you're in a situation where you have a production machine that's been rolled out and you've noticed, hey, all of a sudden, my machine seems to be spinning, doing a lot of disk activity. Things are seeming to be running slow for my web services that are heavy on disk. Like, what is going on with this? And you take a look and you see like, hey, I've got indexing service turned on. And so generally speaking, you don't want that on a production server. So what we can do with Puppet is we can actually execute some PowerShell code. So I've taken the PowerShell script that you would normally use, and I've parameterized it using a template in Puppet to pass through a drive letter. And so this is just a little bit of WMI code. We're going to pull up the Win32 volume class. We're going to set the drive letter, and we're going to set, we're going to set indexing enabled to true, to false, I'm sorry. And we're going to call that through Puppet with a class that I've called disable indexing, that I've stuffed in a module just for the sake of this particular demo. So I'm going to kind of fast forward a little bit to talk about how we're going to identify this node on the master. So at the moment, I've constructed a standard site PP, which is the manifest that Puppet is going to look at first on the master side when it starts to decide what catalog it's going to start to build for the client. This is kind of all standard stuff here. We're going to skip past that for now. And what we're going to look at in particular is those facts that I showed you earlier for web role and for database role. And I'm keying off a value of that being set to true for a fact. So what we're going to want to do right now is we're going to hop over to an SSH into the master. I'm going to do some kind of live editing on the files here. So So I was kind of pre-preparing all these boxes. I pre-installed a bunch of modules. I copied over some of this code. I left some of the things commented out that we're going to be demoing, just to kind of have all my ducks in a row here. And we can see that this has been commented out. And this is going to be including the class for disabling indexing on a machine that's been identified as a web role. So let's save that guy. And we're going to hop over. And we're going to ask the agent to pass its facts off to the master, get a catalog back, and hopefully apply the disable indexing. So you can see we successfully executed the disable indexing exec. Okay, so that's great. So now we have indexing disabled on this machine. But what happens if we run this manifest again? If we run this agent run again? We're going to go through the same process. And unfortunately, we had our exec applied a second time. So this is one of the things you really have to watch out for when you're writing execs, is that when you execute arbitrary code, Puppet doesn't know, unless you tell it, that the resource does not need to be modified. So this is where we start to talk about idempotency and how it's a good thing to enforce in Puppet, because what Puppet does is look at the existing state of things, the desired state of things. If they're the same, it reports back nothing changed. But when things do change and you need to report on that and know what changed, Puppet will tell you that. So let's take a look at our browser again. We're going to take a look at the runs. And we can see that like two runs in a row, we have a log where, yeah, it's hard to see, unfortunately, but where we can see that the disable indexing exec was applied. So this isn't really like a super great solution. However, we can improve on it. So let's take a look. We're going to hop back over to the master again. We're going to live edit the disable indexing code. And here's my little note about, hey, don't forget about idempotency. So what we can do here is we can say, unless this block of code executes and returns an exit 1, then we can skip execution of this fact. So let's save this code off on the master. So I've now modified that manifest that's already living on the master. And let's try rerunning Puppet again. Okay, was that the live code? Did I save it? I think so. Just refresh here. Of course, the one demo that I threw in last night comes out to bite me, but trust me, it works. Yes. So moving forward after that one, which obviously didn't quite go according to plan. Yeah, so basically what we have now is we have a set of how you'd identify facts. We have a system of defining resources, and we have an engine for applying those changes. So let's start to build something a little bit more interesting with that. One thing that a lot of people like to do is when they start up a production server, they like to install, for instance, the Nagios client. So let's take a look at, oops, actually this is just straight up. So, okay, so what I'm doing here is I'm actually pulling a module from OpenTable. They have a Nagios client installer. And so I'm kind of pulling a little bit of a fast one in my code here in that I'm going to be referring to a file off of disk. Generally speaking, what you're going to do here is you're going to have a URL, maybe it's internal file system, SMB share, something to that effect. But for the sake of the demo and trying to not be affected by network connectivity, I've actually stuffed it in the synced folder that's automatically getting shared from my Vagrant host to my Vagrant guests. And we are going to, so override that package source location in the name of the package source. And we're simply going to enable this NS client class. And we're also going to take a look at, we'll keep that in there. So this is just the code that's running, or that's in my local Mac machine, and we're going to need to hop over and do the same thing on my master. So let's hop in here, and we're going to need to delete the comments. Okay. So let's take a run here and see what happens when we try to install the Nagios client. Again, this is just a couple of lines of code. I've imported a module. OpenTable's done kind of the heavy lifting on this one. And we've done a little bit of an override to that actual package source location. And I'm going to turn off my disable indexing thing, or else we're going to get a bunch of noise here. So you can see that it's actually writing to program files NSClient++. It's writing an INI file. And if we hop over to PowerShell and we just want to do a get service, we can see that NSCP is running, and we have NSClient++. So what happens if someone comes along and decides, hey, I'm going to remove this. I don't know what this is. They're a really bad admin. Like, I don't know what this thing does. Oh, let's actually stop the service first. Oops. Otherwise, we'll get some warnings here. We're going to uninstall this guy the hard way. Oops. I'm going to rerun Puppet. So if someone's come along in the interim, they've disabled or removed the package that we intended to install. And we're going to show how Puppet is going to end up remediating this and making sure that the desired state is still the one we expect. Oops, and I was going to disable that. So there we go. NSClient++ has been reinstalled in short order. Okay. Let me just tweak my manifest here and turn this guy off. Okay, so what else can we do with Puppet on Windows? Registry is something that we like to mess with a lot. What can we do to kind of resolve an error that we've had in production? So for a real-world scenario, at a previous position, I had an application that was installed in production that was actually crashing. And it was crashing in such a way that it actually generated a dialog box. And that dialog box, until it was dismissed, didn't actually deallocate any of the memory that had been assigned to that process. And so there was also a process monitor in place that kept spinning up more processes. And so what would happen is the machine would ultimately crash and burn, right? So you can fix that by actually recompiling the application that you've installed, but sometimes you don't have the luxury of doing something like that. There are some Windows error reporting settings that are stored in the registry that can kind of help us out with that. So I have a little application that I built called Crashy App. Crashy App blows up. Crashy App pops the Windows error dialog box. And Crashy App is generally bad for the system health because if enough Crashy Apps come along and allocate enough memory, your system's pretty much DOA. So, oops. Let's take a look at what I did to help remediate the problem caused by Crashy App. So I've introduced a new class that I've defined in my PuppetConf module called Disable Error Reporting. So with this guy, what we can do is we can say that we want particular registry values and particular registry keys to look a certain way. So in this case, we're setting dword of 1 to a couple of Windows error reporting settings, one of which is don't show UI. Why this even exists, I don't get it. But and then there's also a key here called consent, which may not be present depending upon what level machine it is, whether it's 2003, 2008, 2012. That particular key doesn't always exist by default. So what we're going to say is make sure that that guy exists. And then we're going to stuff a value of 2 in for default consent. So this is a pretty nasty thing to have to remediate, but it's actually really easy with Puppet, because we can just say, hey, set these registry values. So let's hop back into our site PP on our master. And whoops, that was the wrong one. OK, so now we're going to try and disable error reporting. We're going to see what happens when we run crashy app. Oops. OK, so we've set some registry values here. And we're going to try and run crashy app again. Now note that there is one slight issue with the way that I built this. In my real production environment, it was a Windows service WCF, and if you compile it in console, sometimes you still get this dialog, but generally speaking, you're not going to see that if it's something that's compiled as a background sort of application. But you can see that the Windows error reporting dialog has disappeared, so we've remediated that particular problem that was affecting us in our simulated production environment. So moving forward, those are kind of some basic, this is something I might want to do, real basic kind of tweaking some Windows configuration kind of stuff. But let's do something a little bit fancier, and let's start IIS. Let's get IIS installed. Let's take an MVC app. Let's deploy that to production, and let's see how that goes. So I'm going to hop back over just once again to kind of look at the facts for our agent. And if we look down at Windows features again, we're going to see we don't see any sort of web stuff installed here at this point. So we have no web server. Through Vagrant, I've mapped port 80 of the guest Windows box to 8080 on my host OS. You can see 8080 is just sitting there timing out. If we want to do, what is it, get TCP, no, get net. I think it's get net connection. Nope, I don't remember what it is. We could check at PowerShell to see that the port isn't open as well. So I've prepared another manifest for doing this. Let's close these guys down. And we're going to look at one that I've called IIS enable. So this one is going to leverage OpenTable once again to use their Windows feature module. So the Windows feature module, as long as you're using a supported version of Windows, which I believe is 2008 R2 and above, if I'm not mistaken, we can actually turn on Windows features. So web server, ASP.NET 4.5, and we're going to make sure that management tools are installed as well. We're also, as part of this installation, going to say, hey, let's flush the default website on this machine, because we're not going to use it. We're going to end up setting up our own thing. So let's hop back on to our master's site PP. And let's turn on, IIS enable class for the node, again, that's been identified as a web role. And let's see what happens here. Spoiler alert, it's going to install IIS. So you can see the dialogues or the local PowerShell UI is being shown just because it's running inside of this console. This is the enable Windows feature work. Okay, so you can see that the add feature was called and the manage site was called, so that we've got all our features all set up and ready to go. We've deleted that default site. We've installed the management tools. So the management tools should now be available. We can hop in and take a look at what. No, I don't want web platform, thank you. And we take a look, there's absolutely no sites in there. So that's great. We have a no default website set up. But now what we want to do is we want to take that kind of the next step, and obviously you want to deploy this application. Just setting up IIS isn't really enough to get you anywhere. So I have an additional class called MVC app. And the MVC app class is going to take a zip file that I've kind of staged locally inside of my Vagrant environment. It's going to copy that to a temporary location, and then it's going to dump it out into C inetpub www root razor C. So this is some razor C CMS application that I found online. You'll see why I'm using it in just a second. And what we're going to do is we're going to call an exec to extract the zip file. We're going to be using 7-zip, which has already been installed on this machine in preparation for this. We're going to tell it the output location. And we're also going to use a creates to say that, again, let's restrict that exec to running only when it needs to run so that we're not getting a bunch of spurious messages back from Puppet saying it applied changes that were unnecessary. And let's do that by taking a look at webconfig. So if webconfig exists, forget about it. We don't need to extract this. We're also going to create an application pool in IIS. And there's a whole ton of settings you can configure based on the OpenTable module. I'm just kind of doing the bare bones kind of stuff for the sake of demonstration. And you also note that I'm using the arrow here to define how these resources are related to one another. So in other words, we're going to make sure we copy the file over. We're going to make sure we can extract the zip file. Then we're going to create the application pool. We're going to create a site for this guy. And we are also going to create a virtual application. And we are additionally going to create some default permissions using the ACL module for the base C inetpub www root razor C directory. So let's hop over to our server manifest once again. We're going to uncomment the MVC app stuff. Let's see how this goes. Okay. We're going to do another Puppet agent run. We're going to see what it can do to grab that zip file, stage it locally, unzip the contents. Okay, there's the zip file. There's the app pool being created. There's the permissions being applied. The ACL module is a Puppet Lab supported module that was developed in-house and has a really wide range of very granular permission settings. So if you're used to using the file resource, this is kind of like file resource on steroids for Windows in particular. So it's a really awesome way to get really dialed in permissions that might be very specific to your particular application. Okay, so let's take a look. Looks like I'm running over here, or about to run over. So we've got this deployed, but oh no, what just happened? So I'm sure everyone's seen this. Anyone who's deployed a ASP.NET site, I'm sure has seen this. So what do we do here? Well, normally we can hop onto that particular machine. We've turned off errors being shown to any remote IP addresses so that only localhost can see errors. But let's say we deployed to server core. Server core doesn't have a browser, right? So our .NET web config is going to need to be tweaked to handle this. So what I've done is I've used the Puppet templates once again to be able to configure the custom errors node that's used in ASP.NET to say, hey, let's, instead of only showing localhost the actual errors that we care about, let's also spit those back out to any remote browsers that may be trying to connect. So we're going to set that to off. OK. So we're going to use that template. We're going to dump it out as the web config file for the particular site. We're going to require that the zip be extracted. If we were running this manifest all in one shot, that's why this requires this here. We want to make sure that the zip has actually been extracted, the directory has been created, that sort of thing. And actually, we'll keep that file open for now. So we're going to run Puppet again. We're going to try to remediate this particular problem of being able to see the errors. And hopefully, it'll give us a clue as to what's going wrong with our deployment. Why is .NET giving us issues? You can see that our web config file is being written. See PowerShell dancing around a lot. OK, so let's take a look. Oh, now we've got an access denied error. So at least now we know what's going wrong with our app. So I already know what the particular cause of this access denied is. We have an app data folder, which is very common in MVC apps. And we haven't put a permission on that particular folder to say, hey, we can write to this directory. So let's. And there's one other thing that we're also going to do as part of this, too, is that this particular application actually requires SQL Compact Edition. And we didn't install Compact Edition. We don't have the runtime. We don't have the assemblies that it needs to be able to be called from our ASP.NET application. So what I've done here is I've set some ACLs. In this case, I'm giving full rights to the app data directory under this particular MVC app. And we can also see that we're using the app pool identity, which we created earlier, to express those particular rights on that particular resource. So let's write that guy. And we are also going to, very quickly, say that we're going to include the SQL CE class. So this is another class that I put together for bootstrapping the install of SQL CE on this particular machine. So let's take a super quick look at this manifest. So what we're doing here is we're using the Windows package provider to ensure that we have a particular identifier for this particular installer and a particular version. So this, if any of you had used MSI provider on Windows previously, you would have known that it wasn't versionable, which is a problem. So you'll get that, that constant report that something needed to be installed, even though it did not need to be installed. So Windows has been the recommended provider for the package resource for a while now. And if you're not using it, you definitely should. We can pass some silent install options, which aren't quite so silent, but in this case, they work. And what we're going to do is we're going to kick off the installer by staging this particular file, which again, I've cheated a little bit and not put this on an SMB share. I've used it through Vagrant sync folders. And we are going to turn this node into a SQL CE node. Let me just make sure. Yeah, I think we're all good. So there goes the SQL CE install. That's their silent install with dialogues. Pretty awesome. You can see our full access rights are being applied to not only app data, but if you actually check the README for this particular app, there were 3 or 4 directories where it's like, I want write access to this directory. Always a great idea for a web application process to have as much write access to as much of the file system as possible, right? And let's take a look at, let's just edit this guy. And hey, look, our app is live now. So we've taken the web config, we've modified it so that we can identify the errors. We found out that we can install SQL CE, we needed those assemblies, and we've also determined that we needed write access to that particular area of the file system. So that pretty much wraps up what I have here in terms of demo. Are there any questions about any of this in particular? Yes.
And in reversing the changes that it made, is it safe to say that that can be a good alternative to, say, reversing the effects of spyware on an infected workstation?
Oh, so you want to do, so the question was, can I use Puppet to do some sort of spyware kind of uninstall, like untweak registry settings that have been modified by spyware to kind of try to restore it to its original state? That's something you could do. I'm not sure how well that would work, just given oftentimes with spyware, there are processes that are running. Some of them are hidden sometimes, and they end up regenerating those keys after, you say, oh, well, I pulled off these keys, everything's great now, right? And then it turns out the process is still running, or there's some still service going or something that ends up recreating all that stuff. So that's a tricky one. I don't know that I've heard of anyone trying to do that. You could give it a shot, but yeah. Any other questions? Or up front here?
So for the custom external effects that you have there?
Yes. Yeah, so as far as what I did, as part of kind of provisioning my node, I gave it a classification. There's all sorts of other different ways to try to classify those nodes. I was using a fact-based approach just for the sake of the demo. So yeah, I kind of, it depends on what kind of environment you're running in. Like, let's say you're in a cloud environment, it's possible that you can publish something to that particular machine as it boots that identifies what kind of identity you want it to have. There's all sorts of different ways, though. If you caught any of the node classifier talks, that's something we're working on. It's not a team that I'm on, so I don't know all of the kind of the details on that kind of stuff. But yeah, does that answer your question?
I think so.
Okay.
So I noticed when you were doing the registry changes, was there any changing in that? Because I know that it's not a logical order.
Yeah, you know what? I might have been relying on.
It just happened to work, but it may have.
Yeah, you may be right on that one. Let's see. That was on error reporting. Yeah, so these actually, so Windows error reporting, these actually, I don't think there's any ordering. The only ordering dependency here would be actually between these two, yeah, right. So technically, to be more correct, but since it's manifest ordering, right, that would execute.
Actually, that particular one, the registry value will auto-require its parent.
Oh, okay. Thanks, Josh.
You do explicitly specify that.
Cool. Any other questions in the back? Yes.
What module is that from?
So the question was, what module is the ACL resource type in? That's in the Puppet Labs ACL module on the Forge. So that is a supported module. As a PE customer, you get full support on that, et cetera. So yeah, that was an in-house module. Yep, go right ahead.
So you talk about the file type cells of steroids. What was that? I missed it.
Could you say that a little bit louder?
You talked about a file type.
Yep.
That was on steroids for Windows.
Yeah, that is the ACL type, right? So the basic problem that we have with modeling the file system in a way that works across different operating systems is that you don't have full parity between the ACL approach and the POSIX approach. So you can't necessarily always round trip properly a file mode that you might expect to use that's a POSIX file mode and have that correctly round trip to Windows. There's some edge cases there. Like, it works in a lot of scenarios, but there are some things to be aware of. And so that's why we built ACL module in particular. A lot of customers were asking for more fine-grained control. Any other questions? Nope, I think that looks like it's it.